Hi folks, another video about statistics, and this time we're going to be discussing another test that you need to know and understand how to use. It's called the student's t-test, and I've put on the front slide some data from what looks a bit like a medical drugs trial. We've got systolic blood pressure before and after treatment. We don't know what the treatment is, but what we're looking for is there a significant difference? This is what happens in a lot of drug trials. You want to know basically, are two sets of data genuinely different? And this is what the student's t-test is for, assessing whether or not two sets of data, or two averages if you like, are genuinely significantly different. And we're going to talk a little bit about how it's calculated and how it's used. That's some quite involved data. I've come up with a silly example that's going to hopefully be nice and simple and let us actually do some calculations. Imagine a question like this: are Scottish people taller than English people? So how would you answer it? Very simple method. You need to go out and find some Scottish people. You need to go out and find some English people. You need to work out how tall they are. And then, I suppose if you've got enough of those samples, you could calculate a mean. So let's imagine we do this and we find out that this is the mean height of a Scottish person over here. And this is the mean height of an English person over here. Is this enough to conclude that Scottish people are taller than English people? Because clearly they are in this to scale drawing. Well, we know that obviously that's not enough to make a completely valid conclusion. We need to be talking about significance here. You could calculate the standard deviations and work out whether there's an overlap. Is the upper limit of the standard deviation up here taller than the lower limit of the standard deviation here? But that's one way of doing it. But the t-test is a statistical test to actually work out whether or not there is a significant difference. So you could use that in addition to doing standard deviations. Right, what I've done here is I've set up a set of axes. So along the x-axis we have the height, and then this y-axis is going to show frequency. But all I've done at the moment is I've plotted on there the average height for the English person and the Scottish person over here. And that's represented by this vertical line here. So you can see that the height of the English person is going to be some centimetres less than the Scottish person, the average Scottish person. And that might look a bit like this if we were to look at the frequency. You remember, we didn't just measure one English person and one Scottish person. We measured a variety, so we might end up with a frequency curve that looks like this. Now, initially, I mean, you could look at this and say, well, these are very different populations, obviously. But remember, what we took was a sample. We did not go and measure the height of everybody in England and everybody in Scotland. So it is conceivable that we got our results because of chance, and that difference in means is simply because we happen to be choosing randomly short English people and we happen to be choosing tall Scottish people. There's nothing we can do about this. Random luck dictates that when you are taking a sample of a population, it might not be truly representative. So we could be making a conclusion here that is not justified at all. We could be telling the nation of Scotland that they're all super tall, and actually they're not. So the statistic we're talking about here, the student's t-test, is designed to work out the likelihood of this difference being actually real, being statistically significant. Now, in order to do the student's t-test, you need a null hypothesis that you're going to test. And the null hypothesis in any statistics is always the boring one. They call it the hypothesis of no difference sometimes. So that's what we're going to be testing here. There is no difference between the height of Scottish people and English people, and any difference between the means is due to chance. That's what we are going to be testing. So what that effectively means is that the populations are exactly the same. They both show the same distribution curve, and actually the means of Scottish and English people should be the same. So what the student's t-test lets us do is it lets us look at the probability of getting different means when we take two samples. In an ideal world, the English people and the Scottish people would return the same mean. But because we're doing a sample, it's not perfect, there may be difference. Now, obviously, you guys can see that a very small difference like this, that's quite likely to occur. You could have a high probability of just getting a few too many short Englishmen or a few too many tall Scottish people. That's quite likely to occur. What's much less likely is that you're going to end up with a massive gap between the means by chance, because for that to occur you'd have to be selecting all of your English people from this part of the population as a whole and all of the Scottish people from this part of the population as a whole. that's not as likely to occur by chance. So students T, the T statistic, is simply a measure of the distance between these two means as compared to the population as a whole. So if we measure that gap there, we can convert it into a statistic T. Now let's think about how that statistic T can be used to work out significance, because all T will tell us is the gap between these two means. In order to figure out whether or not this is a statistically significant result, we need to set ourselves some significance boundaries. And as you know, in statistics, we say 5% is the significant level. If you get a probability of 5% or less of getting your results by random chance, we say, hang on, that's so unlikely, we think it's significant and there's something going on here. So let's have a little look at this slide here. Then the shaded areas here are representing, or are meant to represent, 2.5% of the population up here and 2.5% of the population down there. Or, to put it another way, this box and this area of the curve underneath it, this has got the tallest 2.5% of the population, and this has got the shortest 2.5% of the population. And the fact that my curve is not symmetrical is simply down to the fact I can't draw symmetrical curves in PowerPoint, but they should be roughly the same shape. And these are basically the most extreme 5% of people in our population. Now at the moment, my mean of the English people is outside of that, and my mean of the Scottish people is outside of that. So this would be a non-significant result. We'd actually say that the chance of getting a gap between these means is bigger than 5%, and therefore we will put it down to chance. So this is not a significant result. You could not report that Scottish people are significantly taller than English people. If, however, you were to end up with your means within those extreme 2.5% limits, then suddenly you can say there is a significant difference between the height of Scottish people and English people. Okay. Hopefully that makes sense to some extent, but often the way to get to grips with these things is to do an example. So that's what we're going to do, and we're going to use this equation. Now don't panic. I know you look at it and you think there's a lot of stuff going on there. This is one of those ones that you've got to understand, but it's not one that you're ever going to have to sit down and do the whole thing in an exam all the way through. Okay, you need to know about it and you need to know how the equation works, but they're never just going to give you a table of data and tell you to grind through and calculate everything. So let's have a look at what we got here. This is the statistic we calculate here, T, and all we do is we work out the difference between the two means, so the mean of the English people and the Scottish people, and then we divide that by something. Well, it's the square root of the variance over the sample size of English people, and that's added to the variance divided by the sample size of Scottish people. Okay, what's the variance? Well, we'll get to that in a second. So let's have a look at some actual numbers. Okay, I made up some numbers. I didn't go around chasing Scottish people and trying to find out how tall they are. So these are made up numbers, but hopefully they're kind of representative. These are my English heights in this column right here. Okay. And I've calculated a mean, which is here. It's 153 centimetres. I've done the same for Scottish people over here. There's the mean at the bottom. That's the data. And the first thing you have to do once you've got that mean is you need to calculate mean 1 minus mean 2. Okay, that's what that bit of the equation represents, and that's what I've done down here. There's not a very big difference. That's deliberate, but we'll see why in a second. I chose these numbers to be kind of similar. Okay, so that's mean 1 minus mean 2. Now we need to calculate these variances. All right, what's the variance? Well, to calculate the variance, the first thing I do is I take every single data point, that's all of these here, and one by one I subtract the mean from them. So in this one I've done 186 minus 153 2/3, and that's my answer. And I do that for each point in turn, so 145 minus 153 2/3, and so on. And we get some positive values and some negative values. I then square that, and that is going to be quite a large number in some cases, but the key point here is that they're all going to be positive. I then add up all of these numbers here to get the sum, and I divide that by n minus 1. There are 12 data points. N minus 1 is going to be 11. This is my variance here, okay? And that's my variance I've got there, 505 and a bit. I've done the same for the Scottish data over here. The variance isn't so big, but now I've got my two variances. I can work out this for both the English and the Scottish side. So let's take those variances and divided by n minus 1. So that's what I've done here for the English people. That's what I've done here for the Scottish people. I add those together in this cell here. So that gives me what needs to go into the square root. I then square root the whole thing and I get 8 and a bit. So now I've got my number that I need on the top of the sum. That's this one over here. I've got the number on the bottom of the sum. That's this one over here. Plug that in, do a divide, and I get a t value of 0.165. Okay. Lots of number crunching there, but hopefully nothing too conceptually difficult. This is the important thing here. I've got a t value of 0.165. That on its own does not tell me anything particularly important. I need to take this t value and I actually need to turn it into a probability. I need to know what are the probabilities of getting my means that far apart. Are they far enough apart but not quite in the significance zone, or are they so far apart that actually the probability of getting them outside and into those extreme areas is less than 5%. So let's work it out. Now you don't have to do any calculations here. All you have to do is do a comparison with some known values in a table. You'll be given a degrees of freedom table like this. What we're going to do is we're going to compare my t value with some of these known values, and I can do that if I work out the degrees of freedom. Now the number of degrees of freedom is simply the number of data points minus 2. So I had 12 Scottish people, 12 English people. The mathematicians amongst you will know that's 24. Minus 2, we've got 22 degrees of freedom. Just take that as face value. If you're worried about why it's 22, look it up, okay? But just for the time being, take it as 22 degrees of freedom. And what that means is I'm going to be using this column here. So let's make this slightly bigger. Let's find the 22 column. It's there. Okay. And here I've got different critical values, we'd call these. These correspond to values of the t-statistic. And I'm going to compare my value of the t-statistic to those. 0.165. Well, it's smaller than all of these. And crucially, it's smaller than this one here, 2.07. Because that is the critical value at p is 0.05. That means because my statistic is smaller than that, the gap between my means is smaller than the critical value. That means the probability of getting this difference between the means is bigger than 5%. So I have to accept my null hypothesis. If we can't remember what that is, okay, here we go. And I have to say that there is no difference between the height of Scottish people and English people. Any difference between the means is due to chance. So although those means are different, it's just due to random sampling chance. Let's just go back to this and let's put in some super tall Scottish people. Okay, let's do 190, 191. So these are all giants. Okay, so what I've done here is I've put in some super tall people, 198, and let's go for somebody who's a straight up 2 meters tall. Okay, right. Super tall Scottish people. Now the first thing you'll notice is that my t-values come out negative. And the good news is we can just ignore that. The fact that it's negative is simply due to the fact that I've done the English mean, then minus the Scottish mean from it. I could have done it the other way around. I could have done the Scottish mean minus the English mean. So actually, ignore the minus sign there. My t-value is now 2.33-ish. Well, let's go back to the table. 2.33 with 22 degrees of freedom. 2.33 is bigger than 2.07. What that means is that my gap between the means is sufficiently large that actually the chances of getting that gap through random luck alone are less than 5%. Suddenly, I've got a significant result. And I can report that we're going to reject our null hypothesis, okay, because I've got a p-value of less than 5%. I reject the null hypothesis, which means we need a statement that's kind of the opposite of this. There is a statistically significant difference between the height of Scottish people and English people. The differences between the means is not likely to be due to chance. It's likely to be due to something else. Maybe it's all the haggis they're eating. But that's how you get a statistically significant result in this test. Okay, if you're in any doubt, watch it again and then have a look at the information in your booklet.